Very first data we got from Parker Solar Probe, for maybe 15 minutes, we were thinking there is something wrong with the instrument. Only to realize that no, the instrument is working perfectly, and actually what we are seeing is physics. It's physics that we have not seen before.
The sun is the most important celestial body in space, at least to us here on Earth. It drives weather, ocean currents, seasons, the climate, and without the sun's heat and light, life on Earth would not exist. But we don't understand it as well as you might think. That's where Parker Solar Probe comes in, NASA's first ever mission to touch the sun.
It's a voyage of discovery. It's a groundbreaking mission. It is steeped in history.
This is Nicola Fox, the Director of Heliophysics at NASA.
So the concept of Parker Solar Probe has been around for over 60 years. And so, it's been the most high priority science for us to do, but it was always so challenging technically. And then, finally the technology catches up with the scientists' dreams and we're able to really achieve the mission. But nothing about Parker Solar Probe was easy.
Not only has the probe travelled nearly 90 million miles closer to the sun than Earth, but it's had to withstand temperatures of over 1400 degrees Celsius. Keeping it cool is the job of thermal engineer Betsy Condon. How hard could it be?
So the task of designing a heat shield for something that's going to the sun is immense. Anytime you're trying to do something that has never been done before, while it is really exciting, it is also very stressful. One of the things when you're designing something for space as an engineer is you actually want to keep things quite simple. The Parker heat shield is about 4.5 inches thick.
Yeah. Just 4.5 inches is protecting this probe from thousands of degrees Celsius.
The Parker heat shield is about 4.5 inches thick, and on both sides there is a material called carbon-carbon. It's a lot like the graphite epoxy that you might find in your golf clubs or in a tennis racket. And then in between is carbon foam, and so that together, as basically just a big sandwich, is what protects the probe from the sun. As Parker Solar Probe approaches the sun, and it's in its last approach and closest approach, the front side of the heat shield will be at 1400 degrees Celsius. But the probe itself, the spacecraft where all the electronics are, will be at room temperature, like in the 20s degrees Celsius. And so it's almost like it doesn't even know it's at the sun, and it can do this amazing science.
So thanks to Betsy and her team, Parker Solar Probe will be travelling closer to the sun than anything before, but remain around the same temperature as the average swimming pool. But there's one more detail that made this historic moment extra nerve-wracking for the scientists. The Parker Solar Probe is fully automated, meaning that once the little probe was fired into space, there'd be nothing the scientists could do to control it. Except
there are these little sensors that are the farthest things that stick out behind the heat shield called solar limb sensors. And they're designed that if they light up, the spacecraft knows that it's going off a little off track a little bit, and it needs to right itself. And so it will right itself without any commanding from Earth. We don't have that kind of time to actually right itself. It has to do all that on its own.
So all they could do was hope. On the 12th of August, 2018, after over 60 years of planning, Parker Solar Probe finally launched.
Every single member of the Parker Solar Probe team, when we watched the launch, really felt like we were losing a member of the team.
I worked on Parker Solar Probe for 10 years, and at launch, I cried. It was a very emotional moment. And when I see the launch videos, I still get emotional about it.
There was separation anxiety. There's the feeling that this thing that you've worked on for so long is going to leave and not come back. And really, she is the part of the team that's actually doing the exploration.
Parker Solar Probe has had one extra helper out in space though, Venus. Rather than flying in a straight line towards the sun, Parker Solar Probe uses the gravity of Venus as a giant slingshot, catapulting it into closer and closer orbits of the sun.
The first Venus flyby, I think, was the really key one for everybody. Once that maneuver was done, we were go for the sun at that point.
The first solar pass was really emotional but amazing. Of course, when it was actually in the solar pass,
then that's terror.
We can't actually talk to the probe while it's going in. So
until the spacecraft came back out from the other side of the sun and everything was healthy.
When you get that green beacon that everything is looking good after a solar pass, it is just an amazing feeling.
My God, we've done it.
So after having launched Parker towards the sun, On its 8th flyby in April of 2021, Parker Solar Probe finally entered the atmosphere of the Sun.
It reminds me of 1969. Every time I see the movie when Neil Armstrong touches the surface of the moon,
It's one small step for man.
that was monumental. In a way, it's a parallel to Parker Solar Probe. When you fly through the solar corona for the very first time, nobody has done that before. It was so exciting and also so humbling to have launched this mission, throw it basically toward the sun, and returns you some data that you never seen the like of it before. It's just eye-opening.
Noor Rawouthi has been working on Parker Solar Probe for over 14 years. And in case you're wondering if he still enjoyed it,
It's better by the day.
but the thing that's been exciting Noor more than anything before is the incredible discoveries coming from Parker Solar Probe.
The amount of discoveries, it's way beyond any of us could have imagined. It's just mind-boggling. We are discovering by the day new phenomena in the data that Parker Solar Probe is sending us. Well, the very first data we got from Parker Solar Probe, when we got this data from the fields instrument, we were looking at the magnetic field measurements, and for maybe 15 minutes we were thinking there is something wrong with the instrument. Only to realize that no, the instrument is working perfectly, and actually what we are seeing is physics. It's physics that we have not seen before. And it is these switchbacks, basically the magnetic field will flip over itself, making a rotation of 180 degrees and out again. And it does that in a matter of seconds to minutes, and it is just fascinating. What is really important about these switchbacks is that they carry a lot of energy with them. And that energy will dissipate it into the solar wind in the form of heat and speed. Two of the three goals of the mission is to explain the coronal heating and the acceleration of the solar wind. So the switchbacks could be the smoking gun that actually leads to give us the answer to those questions.
By understanding switchbacks, we could unlock the secrets of solar wind and how it's formed and accelerated towards Earth. Solar wind is not trivial. It reaches speeds of over 1 million miles per hour, travelling way beyond Pluto, and it affects our everyday lives. In 1989, a large solar flare caused the entire grid of Quebec, Canada to fail, leaving them without power for over 12 hours. So think what it could do to a rocket or a satellite. And as well as solving mysteries, Parker Solar Probe is also creating puzzles for Noor and his team to try and solve.
Parker Solar Probe, like any other missions, and answer questions, but by answering a question, it actually poses many more other questions. In a way, that's the essence of exploration. We come to this world as explorer, and we leave it as explorer. On the eve of Christmas of 2024, we will reach the closest approach to the sun ever. That will be 3.8 million miles from the solar surface. It's so close to it. And after that, we do 2 more orbits, and that's the end of the prime mission.
But even after this mission ends, the discoveries made during this epic mission will live on forever in the science and in the scientists.
It is the highlight of my career, and it will be the highlight of my career. Definitely being involved in Parker Solar Probe, it's an honor.
We are really rewriting the textbooks about the sun, and it's amazing to have played a small part in that.
I am incredibly proud to have been part of the Parker Solar Probe mission.
Parker Solar Probe changed me forever. Parker Solar Probe is an enabler in many respects. It emboldened us now to go after very challenging ideas and concepts for future missions. So we are not stopping here.